Hello, it's me again. And we're going to do the week 13, day 1 homework, which I'm kind of nervous about. It seems like it's going to be long as heck. Here's to hoping that it isn't. Read the instructions. Don't jump right into number 13 thinking you have to solve it, because you don't. It says all you have to do is determine the number of solutions that this thing would have. So the first thing you should do when you're trying to determine the number of solutions is determine whether your given information is oriented as a side, side angle side, blah, blah, blah. We said we've got an angle and a side, but just because it's an angle and then a side, that doesn't mean it's ASS necessarily. It could be oriented in such a way where the two sides are on either side of the angle, and then you have SAS. If you have SAS, you automatically have one solution. You don't have to do any math to justify that. It's just a fact. If you have ASS, though, then you have to run through the procedure. You have to run, jump through all those hoops and figure out whether you have no solution, one solution, or two solutions. And I think I spilled the beans to all 3 of my classes that it's a really easy way to tell. If you've got an angle and a side with the same name, then they must be opposite from each other. So that means the two sides couldn't possibly be on either side of the angle. One of them has to be opposite from the angle, forcing you into an ASS situation. So 13 is definitely ASS. So we do have to jump through hoops and figure out how many solutions we've got. What have I done? Okay. So now that we know that this is definitely ASS, we've got to figure out some junk. So I always like to draw a horizontal line and then let angle A be this leftmost angle. It's 36 degrees, so just roughly sketch that in. Again, side A would be over here, so side B would be here at 7. Now, if side A is 2, you might already be betting that that 2 is too damn short, right? It certainly seems like it's too short. But remember, the mathematical analysis that I order you to do is that you have to find this height, the height that would be dropping down from the end of a 7-unit long segment that's forming a 36-degree angle with a horizontal. So we can find that height because that height defines a right triangle. But just like we saw in the previous 2 homeworks, we can just use plain old right triangle trig on this because this height is opposite while the 7 is hypotenuse. So clearly we've got a sine relationship here. Remember SOHCAHTOA? If you're working with the opposite side and the hypotenuse, then you're working with sine. So we know that the sine of the 36-degree angle is equal to the opposite side, which by the way will always be the height, divided by the hypotenuse, which by the way will always be the side that does not have the same name as the given angle. So in this case, side B. So that means our height will always be the side that doesn't share its name with the angle multiplied by the sine of the given angle. So that means our height in this problem is approximately 7 times the sine of 36, which is 4.114. So as you probably suspected, the 2 is not long enough. So no matter how we let that little side swing and dangle from the end of that 7-unit long line segment, there's just no way that it's going to close up a triangle. There's no solution. So for 13, you'll say no solution, which is cool and all, but I'm pretty sure it says right here to justify your answer. And no, the work over here is not enough to justify your answer. You say no solution, then you say because. I don't know. I guess you can just say A is less than H. Although, to really make it sink in, you might want to say A is less than H because 2 is less than 4.114. But whatever, that's it. You do that. Okay, now we do it all again for the next one. Shrink. All right, I got some B's and C's, but I do have a B and a B, It is an angle aside and aside. Because these have the same name, it's definitely ASS. This is definitely potentially the ambiguous case with two solutions. So we better analyze. So draw yourself a horizontal. Sketch yourself an 82-degree angle. That would be almost perpendicular. And then the B, remember, since it has the same name, would be the one stuck to the end. So C is 17. And that actually means I don't have to find the height here. Because, oh, did I just write 17? No, the whole point that I was trying to make was we have the case where this guy here is 15, and then the other side we have is 17. That's actually longer than the 15. So this can't be the ambiguous case because the 17 is only going to fit in at this angle where we've swung it out. And if we were to try to swing it back into a second position, it's going to miss our horizontal line. And so we are at the one solution case. So we'll say one solution. We'll say because. And we'll say it's because B is greater than C. And H doesn't play into our decision here. We don't have to do this work with the sine ratio. If your side that's opposite from your angle is longer than your side that is not opposite your angle, then you automatically are here. By the way, that is case number, I don't know. I never really numbered these, but case 1, no solution. Case 2, one solution. Case 3, it should really be 3 over here in my opinion. I'm going to do that even though that feels awkward. We're talking about case 4. Case 1 is side too short to reach at all. That's no solution. Case 2 is side is the exact right length to fit, but only if it's exactly perpendicular, forming that 90-degree angle. That's one solution. The next option would be when your side is a little bit longer than H, but not longer than B. That's when you fall in that sweet spot and have two different solutions. We should probably call that case 3. And then, of course, there's the option where A is longer than H, but it's actually longer than B also. And that's the case we were just looking at, the case where A only fits if you swing it out wide. If you try to swing it in, it's too dang long. So you're back to having one unique solution. So it goes no solution, one solution, two solution, and then back to one solution when the side is way too long. So I hope that made sense. That's the situation in 14. We are way too long because we're longer than C. So there. Okay, next. We've got a C and an A and a C. Those C's have the same name, so this is, again, ASS. So we do have to test it. We draw horizontal, sketch in a 36-degree angle, same 36 as before. This angle's name is C. So C, being 16, is the one that's supposed to be over here. A is 17. So it should be pretty clear that our height here is definitely going to be shorter than 16, but do the math. Again, we know that it's just going to be the sine of the given angle, 36, multiplied by the side that does not share the name with it, so the 17, the hypotenuse, essentially. That'll give us our h. And so 17 sine 36 is 9.99. And again, how does C compare to that? Well, it's longer than H. How does C compare to A? Well, it's shorter. So this means it's going to be one where that's 16 unit long side. It can swing in here. I mean, barely would get a super obtuse angle, but it can swing in, creating that skinny yellow triangle. It can swing out into this next position over here. There's definitely two solutions. I sneezed. Two solutions, because our C value of 16, well, it was greater than H, but it was less than our A value. So again, maybe if you want to make this make more sense, you're going to say our H value of 9.992 was less than our C value of 16, but 16 was less than 17. So we did fall in that interval. So there's two solutions. And then we do this again and again and again. Are they all ASS? They are. Okay, it would have been nice if we threw in some like sides and stuff to really make you think about it, but I guess we're not doing that. What about this? Sketch. Your angle is 73, so that's kind of tall. That's called A. So B then is 28, and A is 24. So with an angle like 73, this thing will be pretty long. It'll be pretty close in value to 28. So 24 is on the cusp. I'm not sure if this will work out or not. Like, we really do need to test this one. So let's do it. We know that we want to take the 28 and the 73. Our height is going to be 28 times the sine of 73. And so that height is going to be approx 26.777. Okay, told you it was going to be close. This thing is 26.777 and side A is only 24. So it's long, but it ain't long enough. If we let that thing swing back and forth, not going to reach. So this is another no solution orientation of things. So it's no solution because A is less than H. Again, that means the 24 is less than the 26.777 that we calculated. All right, what about this one? It's definitely ASS again. We've got side C. It creates a 30-degree angle. Then side A is 18. Side C is 9. Well, guess what? Let's not forget that there once was a day when we knew what the sine of 30 degrees was. Sine of 30 was a half, wasn't it? More to the point, when you drop this thing down, you're looking at a 30, 60, 90 right triangle. So you might remember that the side opposite from 30 is the short leg, and the short leg is always half of the hypotenuse. So actually, you know that our height is going to be exactly 9, and then C is exactly 9. So we're getting that thing that I called case 2 in the notes, where our height is actually exactly equal to the A value of our side. We're getting 9 and 9. So this is that situation where, yes, our side will fit. If we tried to fit a 9-unit long side in, it'll fit, but only if you hold it at a perfect 90-degree angle. If you tilt it out, it's going to fall a little bit short. If you tilt it in, it's going to fall a little bit short. It's got to be exactly perpendicular or it won't work. By the way, could you show the work over here? Yes. Would say the height is equal to 18 times the sine of 30. So that means 18 times. Sine of 30 is exactly a half. So this is one of the rare times that we're multiplying by sine of something and getting a nice clean answer. It really is exactly 9. So this is one solution. And it's because C is equal to H. All right, this one, B is 88. Are there more after this? Okay, this is a bad set of problems. These are bad. All right, I declare that I'm changing this. We never saw an obtuse angle, and those are important for us to see as well. Because if you look back to our list of rules, there's not really just case 1, 2, 3, and 4. There's case 1, 2, 3, and 4 when the given angle is acute. But when the given angle is obtuse, there's 2 more cases, like case 5 and case 6. So we should be hitting those in our problems too. I wonder if future homework problems will hit on it for us. No, no, yes. Number 29 and 30 will both hit on what happens when you've got obtuse angles given. So I guess for that reason, we can wait it out until we get to those problems. Side opposite is less. Side opposite is less. Ugh, man. So these are both the same case, though. Not ideal. All right, Mr. F is going to invent a new option, option 35, where what are we doing? ABC all the time? I don't like it. We're going QRS. Angle Q is going to be 121 degrees. And the given side R is going to be something. And side Q is going to be, oops, that's a G. All right, so the side opposite from Q is going to be, well, what was it up here? Sorry. The side opposite was 15 and this was bigger. Okay, so I want the opposite side to be the bigger one. So this guy's going to get to be, oh, I don't know, 18. Side R is going to be a measly 12. Okay, that's different. So we've got the obtuse angles. Here we've got an obtuse angle. I guess let's just talk this through super fast. Imagine for 29 if we drew our little thing. We drew our horizontal line and then, whoa, this is weird. We have an obtuse angle. So our angle actually stretches this way beyond 90 degrees. Now that's supposed to be angle A. So the thing not named A, the 28 goes here. Then your other side that's supposed to connect to the end right here, it's only 15. So we're in that situation again where 15 is not long enough to reach this opposite side. So again, no matter how we angle it, it's not long enough because it's a 15 unit long segment that's at the end of a 28 unit long segment. It can't reach down to here. So 29 has no solution. And 30 has no solution too, because we've got the same obtuse angle. We're sticking a 7 unit long thing at the end of a 12 unit long thing, it won't fit. But look at secret option 35 that I just made up. We've got this obtuse angle. It's 121. So maybe it's like this, who cares? But suddenly this time, R is 12, but Q is 18. So this side now is longer than 12. So longer than 12 maybe puts it down to here. We could swing it out. Maybe it would hit the side here. And we get 18. So the deal is, with this orientation of stuff, we would get a solution and would get exactly one solution. So take that to the bank. If the given angle is obtuse, you are only ever going to get no solution or exactly one. The ambiguous case is impossible. You're not going to get two possible solutions. It's either no solution or exactly one. And those are the conditions you should be thinking about. Alrighty, alrighty. Let's go back. Okay, so I don't love that we didn't hit on any obtuse angles here, but we did. I brought you forward. We talked about it. What's happening here? Right, we got this 88 degree angle, whatever. So 88 is close to being a right angle, like super close to being a right angle. So this is 62. So, I mean, we don't really need to do math here. If we're at 88 degrees, then we can tell that our height is going to be really darn close to 62. And this side is only 14. So it's another situation where that side is going to be way too short. We're going to get no solution. But let's do the math anyway. It's going to be our height, that is 62 times the sine of 88. But the sine of 88 is really close to 1. And so 62 times sine of 88 will be really close to 62. So it's really close, 61.962. Yeah. So clearly, like 14 never had a chance. I mean, 54 didn't have a chance. 64, that would have worked. But anyway, we have no solution. And again, the reason why is because This is case 1, that case where the opposite side is too dang short. No solution because 14 is less than h, which I meant to write as b is less than h, because 14 is less than blah, blah. Okay, there you go. Fine, great. So this was the easy part, just determining how many solutions you have. Now you have to actually find solutions. Well, soon you will. First, there's this question, which is kind of a conceptual question. It says, determine the values of b that will produce the given number of triangles if a is 10 and b is 42. So sketching this out, you've got this 42-degree angle called b. So 10 goes here. And you're being asked to find the possible values of b that will create 2 solutions, 1 solution, or 0. Let's start with 0. We know we get no solution only when the b value is too short, right? So we'll of course start by finding h. And then any value for b that's less than h will be our solution here. And essentially we could answer this question right now and say any b less than h is going to give us no solution. But you would be expected to actually find h here and answer more concretely. So you already know what h is. It's 10 times sine 42. $6.691. So when I have asked this question in the past, it says determine the values of b. People read this as determine a value of b. And they just give me one example. They go, b equals 5 would make no solution. That's not what I want. I want you to give me every possible answer. So you answer as an inequality. You say, hey, if b is less than 6.691, then we would get no solution. So you're answering as an interval. So, okay, how do you get 2 solutions? Well, you know to get 2 solutions would have to be greater than the height. So you'd say for that, b has to be greater than the 6.691. But don't be too proud of yourself, because if you give me that, you're wrong. Because don't forget, to get 2 solutions, we also have to be less than the given value of 10. Because once you go longer than 10, you can't swing out into that second position anymore. So you have to give me, a double-ended interval with a min and a max. So it's this. We'd have to be trapped between the height and the other side. Now the one triangle is a little tricky actually, because we know one of our answers is to just go ahead and let b be exactly equal to our height of 6.691. But kind of like we just said over here, we also could let b be greater than the 10, right? If we're greater than 10, we're back to one solution. Oh, wait a minute. There's one value I missed. And also I don't like that. That's not a different color. That should be a different color. What are you connected to? Turn purple. But you. I need you to turn purple too. Okay. Well, no, you'd be orange. There. All right. Actually here, if b is exactly equal to 10, then where are we? Does that give us 2 solutions still or just one? And it only gives us one. Because if we equal to 10 and we tried to swing our side in, then it would lay right on top of itself. You wouldn't have a triangle. You just have 2 line segments that fell on top of each other. If we were exactly 10, we would have to swing out only. We would have this isosceles triangle as our solution. So the b value being equal to 10 definitely belongs in the 1 triangle column. But there you go. There's every possible situation nailed. So maybe I'm going to be stupid here, but let me try this, see if this helps. We've got this sort of continuum. Of course, our side can't ever go negative, so 0 is at a min. Then what? We've got our height at 6.691. But then we've got our other given side at 10. That sort of creates another cutoff. But then our side could grow and grow and grow all the way to infinity. So what's happening? We know that we would get no solution if we're less than 6.691. So anywhere from 0 up to there, but not including it. This is our no solution zone. You bothering me, writing tablet. Okay, finally, what if I'm exactly 6.691? That's the orange. That would be one solution. So this dot is, for a split second, we have one solution. Then comes the zone where we're getting two solutions. That's if we're bigger than the height, but not as big as the other side. So there's this open-ended interval there of sweet spots, you know, between there and there. And finally, dang it, I got to do purple on purple. Come on, man. Better than that, Mr. F. So the number line shall be gray. Look at that precision. You guys see me doing that? It's pretty good. Oh, I blew it. Oh, I blew it. Oh. Oh my God. This video is now unwatchable. Okay, impossible. Can't be done. So finally, the purple zone is for when your given side is equal to 10 or more. Oh my God, terrible. Okay, just make it thicker, bro. Oh, why am I even doing this? Okay, I hope this at least somewhat hammers home that idea that there's a continuum here, right? Your other side is either too dang short, you get no solution. If it's exactly the height, you get one solution, that's the orange. If you're a little bit bigger than the height but smaller than the other side, then you're getting your two solutions. There's your ambiguous case. But if you're bigger than the third side, you get one. All right, I gotta stop talking about that. Let's move on. Finally, at the 30-minute mark, we're gonna actually solve a problem. So looking at this one, how many solutions do we have? I don't know. Let's find out. We sketch. I guess you don't have to sketch anymore. We've done so many practice problems by now that you should probably know what numbers we're comparing, but that's okay. 61 would be like this, pretty steep angle. He's named A, B's 21. It's super obvious that this height is way bigger than 8, right? I mean, this height is, I'm going to guess it's like 15-ish, and we only have 8. So no, it's a no from me, dog. But let's check anyway. Because you have to find the height. I order you to. It's going to be 21 sine 61. And what did I guess? I guessed that it would be about 15. How did old Mr. F do? $18.367. I think I always underestimate. All right, anyway, guess what? Guess what's not big enough? 8. 8's really small. So no solution. Exclamation point. And the good news is you don't have to do any more work, so you move on. Show your work on a separate sheet. Don't forget to do that. Please work neatly on a separate sheet. So there's now a bazillion more problems to do. Hopefully there'll be several that are sort of no solution. Or the one solution ones aren't bad either. They don't take too long. But so we now have to do these 28, 29, 30. So give me a second to just make myself room to do all these problems. Oh my God. Shit. I was muted the whole time.